Ask anyone which direction to send the first generation ship, and they will point at the galactic center. That's where the stars are. It is also 10,000 light years where every settlement stands alone, and the direction gets chosen once. I will argue for the scenic route. It is not the faster one. I am Niklas Järvstrot, rocket scientist and director of Moonbase Lappträsk, our moon habitat analog. Two natural choices when you looked at the galactic map. Either you head straight for the galactic center, where the stars are densest, or you follow the Orion Arm, where we already live. The direct route is the beeline, Orion Arm is the scenic route. The paper asks which is actually better and why. Before any of this, four things have to be true. Let me put them on the table up front. The technical bets. Propulsion. For 1 to 10% of light speed, we need significantly improved reaction drives. Laser or reflected sunlight for acceleration, fusion drives for deceleration at the target. Recycling. We need drastic gains in recycling with tailored onboard tech, cutting unrecycled mass to a few percent per generation. And cryogenic storage of embryos, we can do a couple of years, but a couple of centuries is a different story. The social bet, a city-sized ship is one thing, but a smaller crew will face different problems for staying coherent across generations. Step time is just distance over speed, but the cost of a step is not linear in length, and that changes everything. We need shielding, and going faster means we need a lot more shielding. The closer to speed of light, it goes towards infinity like everything else. Recycling. No loop is perfect, so losses make launch maps grow with trip time linearly. Population growth is necessary for expansion and to avoid stagnation, and the mass to carry population grows exponentially. Well, because the population grows exponentially with time, and we want to have the same. We want to have population growth that we have decided on, and we want to keep that so that we can keep growing population at destination. Over a long leg, the population term dominates because it's exponential. So total cost is roughly exponential in step length. The exact curve depends on your growth assumptions. So the objectives is not the average legs, is the worst one. Minimize the longest single jump. Minimax optimization. With a few long jumps, each leg is more expensive and the longest leg may be unaffordable. With more but shorter jumps, every leg is cheaper, but you have to have closely spaced stepping stones along the way. Let me show you what these routes actually look like. Here, side by side, Soul is the large yellow circle in the middle of each plot. And the galactic center is downwards, and there is a little blue line at the top. That one is in roughly where the center of the Orion Arm is considered to be. The bottleneck here, which says bottle, is mean of the min-max waypoints. It's 9.6 light years for the beeline and 9.7 light years for the scenic route. So it's actually slightly longer for the path that is supposed to have a bit denser star system. But you cannot see any difference in the star system size here, so it doesn't really matter. Let us pick up one of them and look a bit more in detail. We can zoom in here, and you can see that there's a lot of stars, but this is a very deep field of stars, and it's a kind of random hop structure, but it's pretty equally. There's 8.17, 9.3, 8.17, wait, there, 8.17 light years. Here are the two roads side by side. The direct road, the straight line road to the galactic center. You leave the local arm within 500 light years. It's almost not visible. And into interarm space. There are no increased densities that we know of within 10,000 light years. The Orion Arm strategy, the red line here, on the other hand, there are two named clusters, and there is a continuation with approximately the same distances. The mean spacing differs only by about 3%. So the win is not in the spacing as such. It is that one road has the clusters and the other has more randomly distributed star systems. In the clusters is where the Orion Arm route pays off. Once a settlement reaches a cluster, the intersystem steps drop from an average 7 light years in between space to under 1. 7 1 light year steps will not only be a huge saving next to the 7 light year jumps, you would also in the process settle 7 systems in the same time. The first cluster we can see is NGC 7000 has about 10,000 star systems. The second, Cygnus OB2, around 100,000. That is 4 and 5 orders of magnitude beyond a single system settlement at a lower cost. The clusters, not the transit, is where the population grows. And under a light year apart, a message and its reply take years, not decades. Earth ran intercontinental empires for centuries on round trips that long. So, by that standard, a cluster is close enough to act as a single civilization, which the galaxy is not a civilization as we know it. There are many design questions for a generation ship. What one sets the scale? How large a living crew do you send? The tempting answer is none. Just send embryos. Revive and raise with no adults within several light years. The first humans on site would know only each other and their AI mothers, if you like. Lightest, smallest, fastest ship, technically a good choice. But that first generation would grow up with no living culture to inherit. And one software failure has no human to catch it. A civilization could start at the wrong foot and never recover. That seems too big a gamble. The compromise is a skeleton crew stewarding an embryo bank. Real people for parenting, teaching, strategic oversight, and elders to root the children in a past shared with every other human world. That crew would grow in transit, becoming a genuine community before arrival. It costs more shielding and life support and travels a bit slower. The third option is the classic generation ship, a live founding population big enough at launch to carry full genetic diversity on its own, no frozen DNA needed. But it would be orders of magnitude heavier, thus more expensive, with tighter recycling demands, especially on longer journeys. It is the fallback if and until we learn to keep DNA viable for centuries. So the dial is trip length and whether cryogenic storage works. If it does, a skeleton crew stewarding an embryo bank would win on mass, and the bulk of the founding population would then travel as embryos. Which raises the ethic question. Who decides who goes on the ship? Who gets to go, and do we send unborn children as embryos? No unborn child has ever consented to being born, not here on Earth, and it will not on a ship. Parents have always been the one to decide, not only if, but also where a child's life begins. Non-existence is not the kind of alternative. If being left behind were the only ethical choice, we would never have crossed the oceans because that would be equal to saying that no child should ever be born away from where its parents were born. Sending an adult crew doesn't actually change the logic of ethics here. Adult volunteers will have their children mid-voyage, children who would never consented either. Whoever we send, someone decides for the unborn. The ethics is the same both ways. So the choice is not ethical, it's logistical. And the live crew costs 3 to 4 orders of magnitudes more for only marginally more safety. If we solve the problems of storage and stability of a small crew that decides it, send embryos if we can make it safe over the timescales involved. What happens to humanity over the timescales this needs? The numbers are brutal. A signal from one rim to the other takes 100,000 years. A question and reply would take the double, obviously, 200,000. And actually crossing to settle would take millions of years, even at high fractions of light speed. A limiting factor will be rebuilding a sizable population and planet-scale production technology at every step, or just plain waiting for the population to grow. The galaxy is vast, and exponential growth would effectively reset to landing crew size every step on the way. For scale, recorded history is about 5,000 years, our species about 300,000 years. Life on Earth, though, has been some 3.8 billion, so life is old. But no mind, nation, or culture has ever lasted millions of years. What travels is not a people, it's something larger than that. My conjecture is that humanity becomes a galactic superorganism. Independent humans' minds will be acting as super synapses in one distributed intelligence or brain of sorts, spanning galactic distances but also timescales. A galactic amoeba, if you will, or a hyperlysian, combining AI and humans as two symbiotic life forms merged into one organism, with data banks holding the species' memory across eons and updating it across hundreds and thousands of years of the communication, progressively updated with new knowledge, wherever that knowledge appears in the galaxy. So, my conclusion. It is not that the Orion Arm route is faster. It is not. It is that the Orion Arm route lets humanity become a concentrated multi-system civilization with real industrial depth well before reaching the dense galactic core. But all of this, road choice, cluster expansion, embryo transport, is downstream of one prerequisite we have not touched yet. We cannot send embryo ships to Cygnus OB2 if we cannot keep people alive in a small enclosed self-sufficient system with no supply runs, at least for a few generations. Until that exists, this is astronomy, not strategy. I am taking steps today towards that capability. In an old schoolhouse in Lappträsk, Sweden, I am stripping modern production technology down to 4 process groups and trying to integrate them into a closed loop system. The closed loop is mine, where it supplies stuff, and for a generation ship, the mine would be materials mined that we bring on the generation ship. Factory, greenhouse, and the human habitat. Join our expert advisory panel. Semi-annual workshops focused on closing the loop across these 4 groups with minimal throughput of mined materials and energy. All of this is off-site, so no travel is required. If closing any part of the production loop for use in space is something you want done and want help doing, email me. The people who actually build these systems are exactly who I want to build this together with.